Okay, let's take a look at this problem where we will take a look at the mean, the sample variance, standard deviation, and z-scores. This is number 3.22. Let me read it for you. In order to control cost, a company wishes to study the amount of money its sales force spends entertaining clients. The following is a random sample of 6 entertainment expenses, dinner cost for 4 people, from expense reports submitted by members of the sales force. Okay, so I'm moving the mouse here and you can see 157, 132, 109, 145, 125, and 139. And this is Excel, and I've just jotted them down in the same column, column C, in Excel. Okay, so we need to calculate X with a bar over it, which hopefully you understand is the average or the mean, S squared, which is the sample variance, and S, which is the standard deviation for the expense data. In addition, show the 2 different formulas for calculating the variance given the same result. All right, now, I've worked these ahead of time, but let me show you how I solve these. Okay, if you look at this cell, I'm going to erase it and then put it in for you. I'm going to type equal average and hit the left parentheses. Now, what I like to do is jump up here and hit this little function button here. Sometimes it's called the formula bar. And it pops up function arguments. And then we tell it the numbers. Well, we could put in number 1, 2, but we can just give it the range. And you'll see it closes it out. So if I hit bottom, we've got the range in there. And it will calculate the mean for us. Now, as an alternative, let me just copy this over here so we've got another cell that we could work from. I think what I'm going to do is format this right here so it looks like we've got another row. But you could just say, calculate the average by taking the sum of those numbers. Okay, and you either can look up top to see it or right here, close it out, and then divide it by the number of entries we have. And there's 6, so I'll just type in 6. But you could probably find an Excel function that would count that. In fact, it probably is count. Let's see. Count, values, close it up, and sure enough, I equal 135. So you could take it by taking the sum divided by the count of it, or you could take it, divide it by just 6 in this case, right? And either way, you're going to get the same answer. Now, I think I wouldn't need that if I want to do it that way. Oh, and by the way, I want to carry this to a couple decimal places. It's actually 134.50. All right, now, I want to put it back on the fancy way, just in case you ever wanted to use that. I'm going to go ahead with the count method, so it actually counts it for you. So our mean is 134.50. Okay? Now, S squared, you can solve this by using the variance, and we're talking about a sample here. They tell us it's a sample, so we would type in equal, what was that formula again in Excel? It's variance. So what we can do is type in equal VAR, and you see that various choices will come up. This is one based on the population, one based on the sample. Since it's sample data, I'll use sample. I think we'll wind up with the same answer, though. But I'm going to type that, and then it goes left paren. Now I'm going to bring this down, and it'll say, what's the range? And you give it the range, and it will come back with the result. Hit enter, hit OK, and I get 276.7. Now, just to see what happens if we change that to a P, we are going to get the wrong answer if it is based on P. Why don't we read what P says so we know what the difference is? Calculates variance based on the entire population, so it ignores logical values in text in the population. But we're dealing with a sample. So in the case of sample, we use an S here. And if you remember from the formula, the reason is it's dividing either by the number in the sample minus 1 for a sample or the total population, and that's why we've got a difference. Okay, now if you wanted to calculate that by hand, let me show you what that would look like. All right, so I just plotted or dropped in this little calculation here. Well, how would we calculate that by hand? Excel did it very nicely for us. Well, what you do is you take every one of those values and subtract the mean, and then square it. So we would take the 157 minus the 134.5 that we already calculated, then square that, then take the 132 minus the 134.5, again, the mean, square that, and do it for every one of those. And when we're done, we're going to get a total and divide it by the number in the data set, which was 6 less 1. And you'll come up with 276.7. Okay? All right, then I want to calculate the standard deviation. And how we do that is we can either use Excel's standard deviation, or remember that the standard deviation of s squared, the sample variance, is just, take the square root of it. So let's do the Excel way first. It's a sample, so we use a function called equal std, and now we have a choice. Population, the sample, there's a couple other ones based on some other information, but the one we need here is standard deviation S, and then we can hit the formula bar, give it the range again. There's our range. Bring it down, and the formula I think is already closed out for us. And we're done, and we get a standard deviation of 16.63. All right, now, if you wanted to calculate that standard deviation, by the way, I would probably convert that to something similar to dollars, so 16.63. If you wanted to calculate it by hand, you would just take, there's a couple ways. You can either use Excel's square root function, which is sqrt, then tell it what number you want the square root of, right? Close it out, and we should get the same number. Okay, there's our 16.63. Now I want to copy this over. Or you could take the number and raise it to a power of 0.5, right? Hope you guys remember that you take anything to a power of 1/2. 0.5 is 1/2, right? Or, you could actually put it in raised to a power of 1/2. Both of those are going to get you the same answer. And you're going to get the same answer, but I would probably use it this way, 0.5, just it's the way I would do it. And all of those, once we format them, are the exact same number. Okay, so the standard deviation is 16.63. And I didn't mean to move the screen there on you. All right, I want to take one step backwards, though. They also wanted you on Part A to calculate two different ways for calculating s squared. I already showed one, but the other way you could do is you could take the squared of every one of those independently, right? 152nd squared plus 132 squared plus 109, etc. Come up with a number, and then work through this second formula. You get 109,925. So if we use 1 over n minus 1 times the sum of the squared samples minus 1 over n times the sum of the total amount we have squared, what you wind up with is the same 276.7. So if you follow through the math here, we can come up with 109,925. That goes here as the sum of the x value squared, then minus 1/6 times 651,249. And 651,249 then is those values added together and then squared. So that's the other way, but it still equals the 276.7 that we calculated using Excel, and it equaled the other way I illustrated earlier, which is that way right there. Okay, next we tackle Part B, which says, assuming that the distribution of entertainment expenses is approximately normally distributed, calculate estimates of tolerance intervals containing 68.26%, 95.44%, and 99.73%. And hopefully you recognize that as being 1 standard deviation, 2 standard deviations, and 3 standard deviations. So let me show you how we would do that. What you do is you take the mean plus that factor you're considering, right? And we already knew that the S is equal to 16.63. So the standard deviation is 16.63. So if we take the 134.5, which was our mean, and then add in the value we got for the standard deviation, we're able to come up with 117.87 is what we subtract from the mean to get the lower threshold, and then we add that value to the 134.5, right? So 134 plus 16 gives us 151.13. And that gives us the estimate of tolerance intervals at 68.26%, which is 1 standard deviation. Okay, then we do the same thing with 2, right? To come up with 95 is 2 standard deviations, so we put a 2 in front of it. Multiply 2 times the standard deviation, and we come up with what the interval would be at the lower threshold, and we subtract that from the 16.63, and then we add it to come up with 167. And finally, we do the same thing with a multiplicative factor of 3. So 3 times the standard deviation subtracted from the mean gives us our lower threshold of 84.61. Add 3 times 16.63 to our mean of 134.5, and we come up with the upper threshold, 184.39. Next, Part C says, if a member of the sales force submits an entertainment expense of $190, should this expense be considered unusually high and possibly worthy of investigation? All right, well, we've looked at these ranges, and we see it falls outside 3 standard deviations. So if I move this away, we see that 190 is not within the 99.73% interval. So it certainly is outside of the norm. And finally, on Part D, it says, compute and interpret the z-score for each of the 6 entertainment expenses. So if I slide this down, we see how we get that, right? The z for 157, so we say z sub 157 is equal to 157 minus the mean divided by the standard deviation. That's the calculation for a z-score. It's 1.353. And when we work the second one, we see that z for 132 is equal to a negative 0.115. Okay? And you can look at the others as well. And that's this problem, all 4 parts.